Hello everyone. In this video, I will be discussing on fetch, decode and execute operations of 8085 microprocessor. Firstly, coming to the objective of this lecture. This lecture helps the students to gain knowledge in 8085 timing diagram. So coming to the first one, the elements of an instruction. There are three elements of instruction. Number one is opcode, the source operand and resultant operand. The source operand is the value from where we will take the value, and resultant operand is where the result is being put up. So coming to this one, how the process or how an instruction takes place, how an instruction flow in a microprocessor. What happens in a microprocessor or in a machine? How it processes. So the first one is from this a storage memory would be there. From there, a opcode or the instruction opcode would be fetched up. So fetching operation would be done, then followed by this one. After the fetch operation has been done, then there would be a decode. From the decode, it would go for the execute in the ALU, and again it will store back the result in the memory. And next, again, the next instruction would be fetched. Then it would go for an fetching up what is there. And for example, we have taken an addition of two numbers from R1 and R2 registers. So this would be the flow, how it carries out inside the CPU. First, takes the result from the memory. We are supposing this is the memory. It takes a number from the memory. It goes to the fetching it up with data, and it collects over here. Then it goes for the decoding. Then afterwards, one ALU will perform the execution operation and the store banks the result. So when you go for the timing diagram, these are the things which are being replicated in the timing diagram in the form of what happens in each timing cycle. So in a timing diagram, what actually a timing diagram is, and what is the clock of your microprocessor and how it is represented, that would be discussing. First one, timing diagram is a graphical representation. It represents the execution time by each instruction in a graphical form. How much time it has been taken and what are the different T states are there. That would be discussed in the timing diagram. So in your timing diagram, you would be having an different T states with it. T states are the clock states, we can say. So these suitable number of clock states will form a total timing diagram. So coming to the instruction cycle, what is the machine cycle and what is the T state? Coming to this one, T state is a very elementary, or one clock is called as a T state. So these T states depend on the operating frequency. So this operating frequency, if it is of 5 megahertz, the clock period would be 1 by f, which is equal to what? It would be equal to 0.2 microseconds. So that will be the operating frequency. 5 megahertz operating frequency point clock state is what? 0.2 seconds. Now, for one particular operation, like as we have gone for the previous slide, there is an fetch one. Then adding a decoding part, executing part is there. So fetch cycle, you want to read a data from the memory. So this opcode fetch will have one set of operation. And next one, coming to the second one, decoding, executing, and this one. These total operations are the operations carried out in a CPU. All these combines. Now this one particular thing is called as an this is for one instruction, like add instruction is there. All these thing will be performed. And this is called as one machine cycle. The cycle would be repeated one after the other. So the time required to access a memory or input devices is called as a machine cycle. The next one, number of machine cycles required to execute or to complete one instruction is called an instruction cycle. So when an instruction cycle, they may be one or more than one machine cycle. For add is there, adding a number from the memory location, storing back the number in the memory location. You may have different number of machine cycles. It may be fetching a data, reading a data, and storing back the result. Like that way, there would be different machine cycles. Now coming to the clock, as it is shown over here, 1t state, it is represented over here. There would be two things over here, rising edge and the falling edge, positive edge or the negative edge. Negative edge or the falling edge is represented as it is shown over here. This is the negative edge or falling edge. Positive edge or rising edge. And this is represented in that looks like a trapezoidal. The reason is that the operating frequency here we are working with what? 0.2 microseconds. It would be very narrow. So the on period and off period would be more or less equal to rise time and fall time. That's the reason we will be representing the slant line instead of straight lines for the square waveforms. Now coming to the about timing diagrams will be consisting of. So first one is the opcode fetch cycle. It will take four clock states or six clock states. We have taken this one for generalized purpose. So 8085 microprocessor has seven basic function cycles. They are opcode fetch cycle, memory read cycle, IO read cycle, IO write cycle, interrupt acknowledgement cycle, bus add cycle. If you understand all this, then putting up according for our requirement, for our instruction, we'll be binding up this one, then we can find it up one particular on the timing diagram. So overall here in this video, I thought of covering all the concepts, basic concepts about the timing diagrams of 8085, which would be helping in to design the timing diagrams, which would be discussed in the next video. Thank you. So overall here, the outcome of this lecture is to help the students to gain students will be able to define and explain the opcode fetch cycle, execute cycles in 8085 microprocessor programming. Thank you.